So in case of Java, we have the bitwise, these bitwise operator, bitwise complement, yeah, bitwise unary not, bitwise and, bitwise or, bitwise XOR, bitwise right shift, bitwise right shift zero fill, left shift. Then, as in case of arithmetic, compound arithmetic operator, similarly, we can use arithmetic operators as a compound arithmetic operator with assignment. So, and equal to, these are the compound category, and equal to or equal to not, x or equal to, right? We are going to discuss all these with the help of some examples. The first important point is these operators can be applied on integer types only. So you can apply the bitwise operator on long integer, short character, or byte character is also considered as integer data type. So you can apply these operators on the integers only. This is the important point. So how these operators works, that we are going to discuss with the, some examples. So it's very easy, but still I'm going to show you some programs based on that. So I'm going to change uh, this program, right? So we have now two short type variable a and b, and third one is c, and we are assigning some value to these operators. So I'm going to write over here some value. This is, let's suppose, 13 and a is 10. And if you perform some operation a and b, this is the case, a and b. So because a is a short type variable, so only 2 bytes will be allocated for it, and I'm going to show you the value of 10 in binary. So this is the binary value of a in 2 bytes. This is 10, right? And 13, the value 13 is this. This is 13 in 2 bytes. So we have 1, 0, 1. So this is 13 in binary. So as we discussed in the yesterday's class, if you want to represent a binary number, you can use underscore to separate the digits to improve the readability. So I am using over here underscore to improve the readability of the program, right? So when you perform the AND operation, like here we are performing A and B, so what will happen? Uh, what will happen? So the important point here is both of the variables bits will be ANDed. So in case of AND, if both the inputs are 1, the result will be 1. If one of the inputs is 0, result will be 0. So I'm going to write from this side, because one of the input is 0, other is 1. So in this case, the first result will be 0. So the next result will be 0, because again one of the inputs is 1, other is 0. The third bit will be 0, because again the same one of the inputs is 0. And in the last case, because both the inputs are 1, so the output will be 1. Rest of the inputs will be 0. So after the AND operation, you will get this output, right? So this will be the output, and this number is basically 8 in decimal. So the value of C will be 8, right? But it is giving some error are here. So what is the error? Let's check it, and we'll discuss that in more detail. So it's giving us this problem: cannot convert int to short. The reason behind this is, whenever you perform the any evaluation on the short number, those numbers are automatically gets converted into integer. So basically the result of this expression will be integer, right? Because the Java, when it performs operation on the two short numbers, bitwise operation on the short number, the resultant expression will be in the integer only. So it's giving you the result in the integer, so that's why it is giving the problem. So to fix this problem, you can convert this entire expression into the destination type, that is short type, and now it will work fine. So let's check it. So it's giving us the result. We have not printed yet, so let's print C also to check the final result. So this is C, and here I'm going to make the change. This will give you the result 8 as we discussed over here. So I'm going to change the same program. If I make this AND operator, or change this AND operator to OR operator, so this is represented by the single piping symbol. So in this case, or in case of OR, if one of the inputs is 1, the result will be 1. If both the inputs are 0, result will be 0. So I'm going to make here, this will be 1 because both the inputs, first case both the inputs are 1, so result will be 1. One of the inputs is 1, so result is 1. One of the inputs is 1, result is 1. And last case, again one of the inputs is 1, result is 1. So this number is 15 in a decimal, so the value of C will be 15 in this case. So let's check it. So you are getting result 15. Right, then the next problem, on the XOR, we are going to discuss one problem. So here I have used integer numbers. A is integer, B is also of type integer, and so we are assigning a number to A. This number on the right hand side is in the binary format because its prefix is 0B. So these are the 32 bits. Again, to improve the readability, I have used underscore in between the bits. So this number is basically, as you can guess, this is 13 in decimal, and this number is 9 in decimal. Right? So the value of A is 13, value of B is 9. And what we are doing, we will basically discuss these statements first, then we will discuss these two. So through this program, we are exchanging the values of A and B without using the third operator. So how this will happen, that we are going to discuss this with this example. So when this will be evaluated, it will evaluate A, X or B. So in case of XOR, if both the inputs are same, the output will be 0. If the inputs are different, that means one of the input bit is 0, other bit is 1, then the result will be 1. If both the bits are either 0 or 1, the result will be 0. So first operation, I'm going to write it over here. So first thing is, I'm going to copy this entire part to show you how it will work. So here we are going to perform this operation. A is equal to A XOR B, the very first line. So how this will work? So up to this point, it's clear because inputs are 0, so output will be 0. Both the inputs are same till here. This step, both the inputs are 1, the output will be 0.
Reason I joined there was because of that on-site opportunity. I'm having H1
Next,
visa, which is valid and everything, standard and everything. And the visa date
next,
is September, but because of COVID-19 issue, it's all got vanished now, because I can't fly before September. So that is the only reason I'm looking for change.
So this is both the inputs are 1, the output is 0. One of the inputs is 1, other is 0, the output is 1. So both the inputs are 0, the output will be 0. Both the inputs are 1, so output will be 0.
Well,
So this
you
is,
if you want, you can send me an email. I'll just confirm in that email. Will that be okay?
so this is the result in this case. Latest value of A. So this was the earlier the value of A, this was the B, now the value of A will change to this, right? So this is A now, I'm going to write on this side, and this is the value of B after the evaluation of the first expression. Then when this expression will be evaluated, it will evaluate A and B, A XOR B again. So these are the two values. So if I copy it again, you will get this result. See, I'm going to align it. So here will be the change. So this one first one bit is 1, other is 0. So the output will be 1. Other is next bit will be also 1. Third bit will be 0 because both the inputs of A and B are 0. The next bit will be 1. So this is the value of B, right? Because this will A XOR B will evaluate to this, and that value will be assigned to the variable B. So this is the latest value of B, right? Again, the same operation will be performed with the third expression, and I'm going to write it for you the same again. And with this, what will happen? And now the latest value of A and B are, this is B, this is A. So we are going to XOR these two. So you will get 1 at this place because both the inputs are different. Next bit will be 0. Next bit will be 0. Next bit will be 1 because the outputs are different. So this we are assigning to A. So this is the latest value of A. If we check from this, we started with A is equal to 13, B 9, and after the execution of this statement, we have the value of A, 9 as the value of A, and 13 as the value of B. So these three lines basically will interchange the values of A and B through bitwise XOR operator. So let's check the output first, then I will explain these these four lines that we have left. So this is giving us the result in the binary format. This is 13 in binary, 13 in binary. This is 9 in binary, and then I'm displaying the result in over here in decimal as well. So after this swap operation, the value of A is 9 and value of B is 13. So if you want to display any number in binary format, then you can use this code. So here integer is basically I is capital over here, and this is a wrapper class. So what is wrapper class? We will discuss in the coming lectures. So, and toString is the static method of this integer class. So we are calling the toString method of the integer class, and we have passed two parameters to it, the number that we want to represent and then the base, because we want to represent the number in binary, so the base will be 2. If you want to represent the number in octal, then this base will change to 8, and if you want to display the result in hexadecimal, then this base will change to 16. So using over here 2, 8 or 16, you can display the number in binary or an octal or in hexadecimal format. So again, I repeat, this is the wrapper class, and this we will discuss in more detail in the coming classes. So this is all about bitwise XOR operator, right? And the next, before going to the next operator,